Okay, welcome to this course of Fundamentals of Nuclear Technology, Nuclear Physics and Applications. My name is Guilherme Zan. I work here in the Institute in the Nuclear Reactor Research Reactor Department. I'm a nuclear physicist. I work basically with applied nuclear physics. I also have some knowledge on nuclear structure. I work essentially with nuclear detection, radiation detection, and so on. So the idea of this course is to give you a broad knowledge of what we do here in this institute, of uh, what can we do with radiation, why is it possible to do those things with radiation, meaning what's the properties of radioactive materials, what's this when radiation interacts with matter, how can we use it for what we want, and also why can at some points radiation be harmful for you and how to try to shield yourself from it. That's the basic concept of this course, right? This is the program of this course. It's a 5-day course I give usually here in Portuguese. I decided to create this English version, and it's just a video version. So I rearranged things a bit because I thought here we shouldn't need to do 3 hour classes, 2 hour classes. Shorter videos would be better. And so I rearranged it this way. So the first day, we divided the first day in 3 classes. First class are the basics, the history, the compositions, and the units. Uh, because there are units we use here which are somewhat more important, and we should know a bit about them. Second class is about radioactive decay, the mass over energy relationship, the mass deficit concept, what is binding energy, where it comes from, and what is and where does it come from radioactivity, the property that makes some nuclides emit radiation by themselves. Third class, we talk about decay dynamics, which is the kinetics of decay. So it's how it how it evolves over time, the decay constant, half-life, what is activity, the concept, right? And so these 3 classes are the first day of my course, regular course. Then the second day, I also divided in 3 smaller topics. First one is decay energy, right? The Q, which is the energy released in a decay, how you calculate it. And then we talk about how this can be used to see if a decay is possible or not. And we end up talking about what happens with this energy. If I release energy, which form is it released, right? Then class number 5, we talk about nuclear equilibrium and nuclear radioactivity. Essentially, what happens when a radioactive nuclide decays on another radioactive nuclide, right? So we have successive decays. In some cases, this can lead to equilibrium and to decay chains, right? And then we talk more general, we'll talk about natural radionuclides and also natural sources of radiation exposure. And finally, also in this, we have a very short class about nuclear models. They are here because they are part of the program expected for this course, but I personally think nuclear models are an advanced topic that is not that relevant to what we are trying to do here. But anyway, I have just a glimpse of what they are and the 2 basic families of nuclear models. I'll talk to this very briefly. This is a very short class, right? Then on the third day, here's a small thing I changed. I prefer talking about nuclear reactions before talking about interaction of radiation with matter, but you can do the opposite too. Okay, in class I have to do the opposite because of how to fit on the days. But so here, class number 7 is something I usually give on the 4th day, which is nuclear reactions. What are nuclear reactions? How do we determine the energy involved in them? if they are exothermic, endothermic, meaning if they absorb energy or release energy, right? And concepts related to nuclear reactions like cross-section and all that, right? Also on the fourth day I give what is on class 11, talk about that later. Then we have divided the third day of my course, also in 3 classes. Class number 8 is interaction of charged particles with matter. So how protons and electrons interact with matter. Then on class 9 we talk about the interaction of photons with matter. Because they don't have charge, it's a different beast, so we have to talk about them separately. And in class number 10 finally we talk a bit about interaction with neutrons with matter, which is something that's usually overlooked because neutrons are a very complicated and tricky thing to work with. But as we work on a nuclear reactor, I'll talk about this, but nuclear reactors are a very strong source of neutrons, so we have to understand how neutrons interact with matter. Then on class number 11, just remembering each class of these is a separate video, right? Just to make things clear. On class number 11, which is a second part of my fourth day on the regular class, we talk about radiation detectors. How we detect radiation, what is a radiation detector, what can it do and what can it not do, okay? Finally, on the fifth day of my course, I usually talk only about the applications. And the idea here is not to be exhaustive because there are too many applications to talk about, and if you have any doubts you can come to me because there are plenty more of applications I don't have time to cover here. Some of them I know something, some of them I have to study if you ask me, but please feel free to ask me if you want to know something about an application I haven't included here, sorry. So I divided this into 6 small classes, and these are very small just because I don't think we need to put them all together. The basic concept here is to give you an oversight of what we can do with nuclear, the applications of nuclear energy, nuclear power, nuclear decays and everything, and also to give you some practical examples where some of the concepts we have developed on the previous days can be put to work. So we have class A goes from 12, goes from A to F. First we talk about largely an introduction and what most people know, which is electrical power. On the second class we talk about applications in medicine and health. Most of these applications you already know or have some ideas. Some of them you have never heard of, so I think that's good. On the third episode we talk about sterilization, essentially, which can go several ways, right? Can be with food, can be with surgical equipment. So we talk about how we use radiation to sterilize things. Then on the next short topic we talk about industry and environment. There's plenty of applications in industry and environment, and I believe most of them will be quite new to you. Finally, on the second to last, we talk about analytical techniques, how we can use nuclear physics and radiations and nuclear reactions and to determine the compositions of things, right? And finally, on the last class, right, we talk about the applications in imaging and art, because there are plenty too. Okay, I hope this structure here gives you one idea, so you can, if you want to see my classes, you can follow essentially what of these videos fall in what day of the course, right? That's essentially what we'll talk about in this. This is a short bibliography. In English, I would really advise you this Kaplan book is more of a nuclear physics book, as the name implies. Very didactic, very simple, could be good. And this Loveland and Morrissey here is very, very good. Also very more recent. It's a very interesting book, not so easy to find, but if you can, I advise you to take a look, because it should be a good thing to follow up the course. There's more things here. Uh, Most of them, I think, are not really. They can help you with one or another thing, and the last two texts are in Portuguese, so I don't think they'll be really useful. Well, the final grade will be, as this is a class, even if you're watching but you want to take the tests, I advise you to come to my classes because we can talk. You can ask me questions in English and I answer no problem. And in the end of the class, we can discuss things also. But essentially, this is a course, there's a grade. And the grade is 80% a test, come from a test, which is on the last day, on the 6th day of the course. And 20% is from exercises. You'll find two types of exercises in my site. The first ones are just, it's a large number, it's just exercises that I could use in a test. Not just exactly those, but very similar to what will be on the test, so it's for studying only. There's a separate, usually 2 to 3 exercises list, which is for grade. It's part of your grade, and the idea in this here is that we discuss these results. You come to me, you do it as soon as you can, and then you come discuss and you discuss with your friends. The idea is that this grade here should be used to increase your final grade. So the idea is that you have the best grade possible on it. So don't be ashamed to come to me with questions, doubts. If you can't understand something, you can discuss with your friends. You can do it together. I just ask you to, when you deliver it, I need it individually. Even if you've done with friends and everything, I need you to give me an individual exercise list, right? Well, there's the website here. Still haven't figured out really how I'll put the English parts in here, but they will be there, right? I'm just trying to figure out the classes first. Okay, but this is the website. Some final observations, yeah. Slides, exercise lists, and all are in this website, as I told. And there's some useful sites and software. Isotope Explorer is a very good site if you want to. It's an app for the computer where you can see decays, nuclides, how they decay, half-lives, and all that. Isotope Browser is essentially the same thing, but it's go for your cell phone, either Android or Apple. You can have it for free. You find in the store from even Apple Store or Google Store. Just go there, type Isotope Browser. We use it almost daily here, right? Because there's just certain things we can have in our minds. For the rest, it's better to rely on. And these two are created by the International Nuclear Energy Agency, so very up-to-date data and very reliable data. There's this interactive chart of nuclides, which is very good if you want to see things in a larger screen or something, right? National Nuclear Data Center from United States in Brookhaven. It's one of the reference places to do things like this. There's the nuclear wallet cards, which is in the same NNDC site, where you can see basic data on all known isotopes, right? And for a more professional approach, if you need to know more about nuclei, this evaluated nuclear structure data file, you have all nuclear data that is known about that, each nuclide. So that's everything there, very complete, which also means maybe it's not so easy to find the information you want because there's too much things there, right? So essentially, that's what I had to tell you. This is the first class. This is class number 0. I'll be releasing those in a website. Please come to me if you have any doubts, any questions. I know there's some problems here and there. Here, for instance, I forgot to translate the title here. Yeah, it's final observations. There's some mistakes. It's the first time I do this in English, so there should be some mistakes here and there. Please come to me if you have some questions. And any questions at all, because uh, the farther we go with a doubt, the harder it is to help you with it, because things tend to pile up. So every time, you know where my if you're one of our students here, you know where my room is. Otherwise, my office is. Otherwise, you just ask me, phone me, send me emails. The idea is to help you as soon as you have a doubt, because, as I told you, if we let them pile up, they can get quite cumbersome and quite hard to solve in the end. Okay, so thank you. See you on next classes. Bye.